I have a background in tracking technologies and wildlife conservation and using them in that sector. I hadn't actually used those skills and those technologies in the humanitarian sector until I met Philip. And he explained the project and said, is it possible to track where these malnutrition supplies go forward? 2 years later, I'm now sitting at the airport in Addis, having just installed a solution that we believe solves that problem. And it all came from Philip and his original idea to create what he called GeoSeals.
I'm Philip Cockerell. I'm a statistician at the Foreign Commonwealth and Development Office. I'm a pioneer with the Frontier Tech Hub and work on the GeoSeals project. So this storehouse has currently got a stockout, which means there's nothing in here. When I came to Frontier Tech, the problem that I had in mind was a problem that I faced in my job. Our team was supporting delivering humanitarian aid in a very difficult to deliver context, a conflict context in Ethiopia. And ultimately, we needed to know where this aid arrived at. In this health centre, the RUTF goes from the storeroom into this room here, which is the nutrition room, and this is where the nutrition officer will give the mother and child the nutritional supplements. We tried to understand what every person in that supply chain needed to know and how this could benefit them in their job. And so we got many different perspectives and brought them back and built them into our design.
So I saw Phil's proposal through the Frontier Tech consultation, and I gravitated to it in part because we were dealing with a crisis in Tigray where all communication had been cut off. We didn't actually know what type of supply was going in, where it was physically located, if enough was actually in the health centers. Phil's idea really sort of presented a potential option that we could use, even if it was, a bespoke bit of technology that still needed to be developed. It was still very much needed.
ስሜ ገነሽ መንገሻ ይባላለሁ። ስራዬ ቢኤስሲ ነርስ ነኝ። የስራ ድርሻዬ ኒውትሪሽን ፎካል ፐርሰን ቦኮ ሄልዝ ሴንተር። ያው እንግዲህ እንደ ሄልዝ ሴንተር እንደ ወረዳው ቦኮ ሄልዝ ሴንተር ቆንጆ ነው ላለው ነው። የሎጂስም አማሬ ጫላ ነው። እድሜው 59 መንዝ ነው። ስቴዝ ደማ ግሬድ 2 ኑትሪሽን እና ሲቪር ኑትሪሽን ስላለው ነው። ሲቪር ኑትሪሽን ስላለው በፕላምፕኔት ዋን ራቡ ኡፍ ፕላምፕኔታ ዋን ራቡ ኡፍ ከነማፍ ፕላምፕኔን ይኩን ማናደ ዴቢቴ ቶርበን ፉታፍ ጀቹ ፕላምፕኔታ ከነ የጓፉቴ ዳይምኒ ቶኮፍሌ ከነሙን ቀቡ ፕላምፕኔን ይኩን ደዋ ዋንቴፍ ደዋ ጉያቴ ፍሪያ ፍራፍሩኛ ተሲንጀዴራ ቶርበኒት ፍሪ ሶዶሚ ሸንፉታፊ
The ability to track medical supply is a general issue of concern across all of Ethiopia. We often have stockouts in different locations. We have often locations which are unable to communicate and ask for a resupply. The impact of that is that if you have one mother taking their child for treatment of malnutrition to a clinic, and if that clinic doesn't have any commodity to supply or to treat that child with, the knock-on impact is far greater than just that one individual. She will go back and tell the rest of the village that the health clinic doesn't have any supply, and so the health-seeking behavior is immediately cut from that. So the ability to actually know that that health center has the ability to deliver health services is really crucial to being able to sustain a health system, but also maintain health-seeking behavior from a wider population.
This supply is ፈላጊነቱ ijoolleen umtuun kun yoo fudhattu ta'e ni dhumtika ni du'amte ni du'u kanaaf
Ethiopia has one of the largest caseloads of acute malnutrition. This is driven by a number of different features: conflict, drought, food security concerns, floods. The sort of pipeline that's needed to support the treatment commodities for malnutrition are some of the largest in the world, if not the largest. And that means that we need to know exactly how much stuff, how much product is in each of the regions and each of the health centers, so that we're not oversupplying one while another health center is stocking out. We also need to know in those remote areas that that health post has enough commodity for the catchment population.
Essentially that will go on the wall, and then within that it houses all of these.
All the things.
Okay. This project would not work without partnerships. I found Arabada, Alistair and Ruby. They've got the technical expertise to really say what is possible. I got to know UNICEF, the World Food Programme, and the Ministry of Health in Ethiopia, who are experts in the field. They know the challenges of delivering aid across a very large country with poor kind of infrastructure, poor roads, challenges with communications, etc.
I'm Ruby Hill and I'm a design engineer, and I work with the Arabada initiative to develop their products, and I'm working on the GeoSeals project as the sort of lead engineer. The best way to explain how it works at the moment is that we go from sort of pallet level shipments down to sort of individual boxes. And the individual boxes are the things that matter the most, because they end up going to the health points and the remote clinics. This is kind of like GeoSeals Mark 1.
That's where the GPS is.
So this is actually where the RFID chip is. So that's going to pick up these chips. So these are like little stickers. So yeah, there's lots of different types of antenna on there, and they each have a little chip. And each chip can store lots of information. So we can put things like the date that the box was sealed. We can also put like where the box has been, and if there's any like attachments to it. So is it like RUTF or is it RUSF or?
So you pre-program these, like when they're on like the reel of presumably like hundreds of these, and they're all pre-programmed before they get stuck on the boxes.
Or they can be programmed as they're put on the box, but at the moment I think we're going to pre-program them and just cover them with like a coloured label, so people know like where the shipment's going. So like if it's going to one of the clinics or one of the health points, we have a different colour, and then they can just slap it on there, which will be quite quick. The way GeoSeals works is we have these labels which we stick on packages, and when they pass through our detectors, we can detect which packages have gone past the detectors within a certain range. So that data is then sent back over a cellular network, so like a mobile phone network, and we can then put that data together to find out what packages are in these different locations. So we have these GeoSeals detectors at main warehouses, but also in the small remote clinics. So they run off solar and they count packages in and out. So we'll then be able to know how many packages are there, when they arrived, and also when they left. So we'll be able to get an idea of how much stock is in each location at any one time, and also the lead time over the system, because we'll be able to know when it left the main warehouse, when it entered the next like low-level warehouse, and then when it actually reached the people that are using it. So that allows people to make really important decisions about the data and how they're going to manage that stock throughout the supply chain. What's really nice about the Frontier Tech Hub is that we actually get to experiment and try and find out in a risk-free way whether or not this is going to work or not. And to have space to maybe get it wrong is really important.
Because we were also talking about having a power out option, weren't we? So that people can charge up their phones and charge up lights, torches.
Yeah, I think that's super important. That's like I would really like that to be something that we can incorporate. I've got to build 13 GeoSeals detectors to go out to Ethiopia in January. Then I'll be packaging them up, putting them in a box and sending them off with Alistair.
I'm Alistair Davis. I'm the director of the Arabada initiative. We are at the UNICEF warehouse, and there are over 200,000 boxes of malnutrition supplies. And we're here to install a GeoHub. And we're here to test if it works. We're going to connect it to the internet and have data stream back to the dashboard to show the UNICEF team here that we're scanning tags. We can monitor all of the UNICEF nutritional supplies. And I'm here today to help install it. Stick some on the side and on the top, Greg. So the warehouses are really important to us. So this is where the flow of nutritional supplies starts. We want to work with the warehouse team, put our GeoSeal hubs up, and understand when it left the warehouse and where it's being distributed at scale. So we're going to work with the team here to tag them When the forklift trucks take it through the doors and out to be loaded onto trucks, they'll already be tagged. We'll detect that nutritional supply flow moving and we'll see where it ends up.
My name is Chalto Abdurrahman. I'm from World Food Program. So my position is Nutrition Program Associate. So the hardest thing about our job is we have so many food distribution points. So we need to reach all affected children and pregnant and lactating women. We are installing GeoSeals application to the warehouse where the WFT commodities is stored. So that software will catch or will trace commodity stock. So this is a very good software for us.
So Charity has been a real star and a real asset to the World Food Programme, and I hope we get to work with her for many years to come.
Technology helps us to deliver commodities on time, even earlier, before getting the stock low. So this is very important technology for the program. In the last 3 days, we are working at Alastair and the team coming from British to install this software. So we have two students from Harama University, which will going to monitor this software.
Power is this socket here. The middle one is power. We may get back in a week's time and the solar panels haven't charged the batteries enough, or the SIMs have stopped, or anything. It could be like a technical issue with the device. Having what we call remote hands, so a local person, these are our students, to go to a GeoSeal and look at one of our messages from the team, from the engineers, and say, hey, can you open it up, change this cable, we know this is a problem, maybe change the firmware on it, plug in your laptop. That is by far the most, needed thing to get this project to work. Remote hands are fantastic. We can't do it from back in the UK. And you need someone who knows their way around the computer.
My name is Maraf. I'm a computer science student. My research on natural language processing. We know only the theoretical part, how sensor networks work. We know, but after I joined this program or working with Arivada, I'm happy. I'm seeing how sensor networks detect objects, how it works. I see it in practical, so I am happy to work with them.
And you have
For first time, the concrete is so hard to drill it, okay? Since we are a student, I'm not involving in such a labor work. But since it is the part of this project, I should have to do it, okay?
No, it's a big job asking master's students to come and join an international research and development experiment. That's a big thing to ask, but they really got stuck in. And pleasure to work with you. Frontier Tech Lab is my friend in here. I would say the people we met were kind, very supportive, and very open to supporting us in terms of getting involved.
The main thing that I want to get out of the trial is I want to get the data that shows that the system can track things, and it can track things and it's useful data. The output of this, although we have the technology that's going into these clinics, the output is data, and that data needs to be open and easy to analyse and give the people who are making these decisions about the supply chain the right information to make those decisions.
So when you guys ever come here to update it, if you ever did, you just do this. You take it off the wall, unscrew, then unscrew these. This was a project from the ground up, from the grassroots, trying to solve the first challenge of it must be low cost. The second challenge, it must be fit for purpose. It must work and survive in a community where there's no constant power, where cell phone access is non-existent. And these are problems that we solved together as a team with Philip from the FCDO and the engineering team at Arivada. And we've just installed our first 6 hubs, which solve that challenge. And this is the first trial of what I hope is many as we go forwards. And I'm very proud of the whole team and all of the brilliant support teams that have helped us to get to this point.
The partnership in all of this has been a real mutual benefit in bringing people that know the technology, people that understand the problem into the same sort of space where we can co-design and co-evolve a technology solution.
I do believe that the GeoSeals project, although it's very small, it can have a really large impact, and it can be applied to millions upon millions of pounds of aid that is delivered in Ethiopia. So it's that small amount of money that can make a really big change in terms of improving efficiencies and effectiveness of delivery.